introduce you to him. He's the chairman and CEO of Vital Connect, that is doing phenomenal advancements in sensor technology. And how cool to be able to have this discussion at CES this year. Sorry, I was just going to give you a quick timer.
Thank you, Jill. Thank you for this great session that you're organizing and for your invitation. I have a presentation that is going to be loaded in a minute. But before I get to that, we are a biosensor company that we started the company doing the usual things that you expect, such as heart rate, ECG, blood pressure, things of that nature. But one thing that really got us into looking into fall detection was the statistics that we saw that about 1/3 of people over 65 years old fall once a year. And if you think about that, if there was any other disease, if 33% of people over 65 had a heart attack or any other condition once a year, there would be outcry of, trying to do something about it. But that has not obviously happened for fall because we kind of think about it as an accident. But it really is not an accident when it comes up this often and every year for individuals. So what are the things that are out there already? Essentially, the technology for the fall detection involves large, uncomfortable devices that most people do not want to wear. And in fact, sometimes people think that may cause them discomfort and so forth. At Vital Connect, as I said, we went about designing biosensors, and we designed this biosensor that I have in my hand. This biosensor keeps track of your heart rate, ECG, heart rate variability, skin temperature, breathing rates, and a few other things such as walking and posture. But when we look at those statistics that I talked about, we thought that if we should also add the fall detection to the set of things that we have. One of the other things that is unknown is that the statistics of 33% is for healthy people. People who are actually sick or in hospitals who need clinical care, they actually suffer more than 33%. And for one reason or the other, that statistics is really not published, but we know that it is larger. So we thought that we should do something about that. And once we went through the clinical studies that we were doing for our product, we essentially added a component to that, which involved using a clinical grade type of testing. We had 106 people that we did for all our other measurements. We did that sort of rigorous study also for the fall detection. We had 30 people that were healthy and they were doing falls to make sure we do have some falls. And then we also got 76 elderly people who were participating in our study to help us with our ECG and everything else to do what we call activities of daily living, meaning that they just went about their way and lived their lives, and we keep track of if there are any false positives. Having very few false positives is very, very important because it has been proven that if the rate of false alarm is even 1%, people stop using these things because you don't want to be bothered by your loved one or caregiver that you fell when you did not fall. So that took us a lot of work. And in fact, after we did all of this research and come up with this product, the study became so rigorous that we submitted that to FDA when we submitted all our other data for getting the heart rate and so forth. And it was sufficient amount of data that we're the first device that was approved by FDA, cleared by FDA, I should say, for automatic fall detection. And again, I want to underline automatic, meaning that the patient doesn't need to push a button or be observed by anybody. Once that impact is done, a very sophisticated algorithm looks at all the dimensions, and it would also know that it should fall occur, what is the severity of the fall. So we think that this technology is a additional benefit for people who need to be watched over for heart rate or any other condition that you may have in a hospital or a care facility. And this addition would help us get to those people quickly and save lives. This work has been done over 2 years, and again, it's very rigorous in the sense that we did not want to have the patient involved in any way and be done all automatically. So that's the sort of the outline of the work that we did, and thank you again for your invitation and your attention. Yes, sir?
In your false positives, what percent did you have false positives? Less than 1%, like you said?
Yes.
And you submitted that to FDA?
Yes.
And how long was that process? The reason I'm asking is because there's a lot of systems out there. I'm sorry, the reason I'm asking is there are a lot of systems out there for fall detection, and they're all claiming that they're going through a process of FDA. And so I'm just wondering, was you paralleled your process of fall detection with your other processes, and so what time frame was that since you submitted? Did it take a year or 2 years?
Oh, yes, yes. Getting this device, we are been in business in 4 years, and our FDA clearance just came in last summer. So it was a process of 3.5 years of developing all the algorithms, doing the extensive clinical studies, submitting, and as you know, once you want to get the FDA clearance, there are questions and further information needs to be sent. Yes, so it was fairly involved and extensive both in time and effort.
And if I follow up on that, you have all this data accumulated. What do you do with this data? Do you do monthly data, week data, whatever the customer wants, or
But-
prescribed by physicians?
Well, this device is a clinical grade device, so it has to be prescribed by a physician, yes. And you know, what the physician or caregiver do with the fall, you know, obviously our first hope is to immediately go and get that person and help them out. And then we obviously have additional field information that could be used for research later on. Yes. Okay. Yes, sir.
It's prevent people from falling.
No, this device, the device that we currently have is after the person falls. There is data that if someone takes a fall and care is given within the first hour after the fall, the result is dramatically improved compared to someone that falls and is, you know, found regrettably the next day by a loved one or by a neighbor or things of that nature. Okay. And in fact, as to answer to a colleague's question, since this is a clinical device, a lot of our applications are in hospitals. And a lot of falls happens in hospitals when the patients get up in the middle of the night to look around and they fall. And sometimes even in hospitals, the nurse would not immediately notice that until the next day. So getting immediate care to the patient is extremely important, and this would immediately get that notice to caregiver or nurse.
With regards to your question, your statement. Hello. With regards about what you said about hospitals, your if I may call it a patch, your sensor, if it monitors the patient, theoretically, when a nurse or caregiver assists the patient, isn't there a record of it because you can detect that as well?
Yes.
And if that's the case, doesn't the hospital or the nurse union object to that because now you're monitoring them and not just the patient?
We have not encountered that. The people that we've worked with, that they all obviously want to provide the best care for their patients. And if a fall happens and they found out the next day, that's even worse than knowing immediately. So I think I don't know how we're doing on time. And I think what I wanted to do is I spoke about most of these things. And on this slide, if we can get the animation going. It is Bluetooth, yes, sir. Where do we put it in the patch? The patch has a centerpiece that has, it's kind of more solid, and we put it there. Or where do you put the patch? The patch is on the chest because remember the first or original plan for the patch was for the cardiology and heart rate, and obviously for getting a good single lead ECG, it needs to be on the chest. We've done studies to show 3 areas, sort of upper chest, in the middle, and below the breast are the places that is very effective. Yes, yes. In fact, that was the last page of my presentation. Once we get that, I'd be glad to. But these things always work before the conference when you work with the AV gentleman and everything works perfectly. And then as soon as you come here, all kinds of things happen. Yes. So actually, if we go to the last page, we have all those statistics. Okay. One more? No, one more. Next. Maybe I. Yes. Okay. Yes. I'm sorry. Those are the statistics that we gathered. And as you see on that table, that is like an eye chart to the right, there are all kinds of tests that we do to pretend that you make a fall, and the ones that you actually do a fall. And then we follow up with the activities of daily living. Now, if you look at the sensitivity and the performance is 95%, which means you lose on 5% of the falls, but the field study and the experience shows if you want to increase that and increase the false positives, people do not use it. So the important thing is to have very low false positives, and in this case is 0.0027%. So that's what the optimization was at the time that this data was gathered. Obviously, just like any other company, we keep improving our performance and hope to keep move the 95 to close to 99% and decrease the false positives.